The remainder theorem allows us to determine the remainder of a polynomial without actually dividing. So here's the remainder theorem. If a polynomial function f of x is divided by x minus r, the remainder is f of r. That just means all we have to do is take the value of r and plug it in, quote unquote. So for example, we can find the remainder when f of x equals x cubed minus 2x plus 7 is divided by x minus 1 by just evaluating f of 1. What is f of 1? Well, f of 1 would be 1 cubed minus 2 times 1 plus 7. So that's 1 minus 2 plus 7. That equals 6. Well, what the remainder theorem says is 6 is the remainder if we divided f of x by x minus 1. Let's check that with synthetic division. So we put 1 up in the little box on the left. We represent every coefficient. If we have missing terms, we put zeros for placeholders in descending order. So I have 1 for the 1x cubed. I have 0 because there is no x squared. Negative 2 for the negative 2x, and 7 for the constant. Bring down the leading coefficient of 1. Multiply and add. So 1 times 1 is 1, 0 plus 1 is 1. 1 times 1 is still 1. Negative 2 plus 1 is negative 1. Negative 1 times 1 is negative 1, and 7 minus 1 is 6. 6 is the remainder, as the remainder theorem already told us. So let's write x cubed minus 2x plus 7 in its divisor and quotient products. So it'll be x minus 1 times, remember we take this 1 and we knock it down a degree. So this is going to be x squared plus x minus 1. And the remainder is 6. So x squared plus x minus 1 plus the remainder. So notice, if we get a remainder of 0, we know the divisor is a factor of the polynomial.